Hi, everyone. Good evening, good afternoon. This place is so bright, it's like deer in the headlights. So I'm going to make a quick show of hands of how many of you traveled from outside of California. All right, for all of you, I think we owe a big thanks to Freddie and the entire AI Med team for bringing us out here. I come from Seattle. I cannot tell you how appreciative I am of the weather here. And in healthcare, right, so much work happens behind the scenes that, I think it would be right for us to give a warm round of applause for Freddie and the entire team that put this event together. So with that, I am Sunny. I'm the Chief Growth Officer at Kaiser. And what we're going to do today is we're going to talk about, saving lives with data science. And in that context, there is really two parts to the conversation. We are going to talk about getting the data ready for AI, which you heard a lot of very good content on. And then we're going to talk about getting that AI in the hands of the doctors, which is perhaps the most underappreciated skills in AI these days, right? So what we're going to, contrast that is with this, right? It's fun talking about AI. It's great. You are on an ocean, on a cruise ship with your hands spread out, singing woohoo. And then 10, 15 years later, you have that, right? And I think the journey of AI is going through a similar paradigm right now. We work with a lot of partners across the world, including NHS in Scotland. You'll hear about that tomorrow, Ministry of Health in Singapore, and lots of systems in US. And we see this continuum of progress, right? And I'll give you this marketing bullet point. It's basically BI, AI, ROI. And that's the journey. There is no two ways about it, right? And we're going to talk about AI, which is sort of in the middle, but understand that unless your BI is right, you are just making very advanced decision with high degree of wrong decisions with high degree of confidence. That's what it is, right? And the unique thing about Kaiser and a lot of other health systems is in the business model design, where you are really pointing your intellect at certain things that will yield you better patient outcomes or better margins, right? So, so between BI and ROI, there is this amazing magical thing called AI, right? We will talk a little bit about AI, but not too much. To do that, who we have here is Drew, who's let me quickly show who Drew is. He is the lead data scientist at Kaiser, and if you do not know him, at Kaiser Health Innovation Group. But Drew is also an astrophysicist, right? So, and I don't want to scare you saying it requires a rocket scientist to do this, but we have learned so much from Drew and his team about how to really think about data in a strategic fashion across a large organization, not just for a single project or a single pilot, but how do you really think about data as a unique differentiation and asset, right? And then we have Dr. Funahashi here, and we are going to learn a lot from Dr. Funahashi on how do you take the amazing thing that Drew's team and the rest of the organization does and get it in the hand of the doctors, right? So that's sort of the construct of this session. We are going to spend about 20 minutes talking about Kaiser's experience as they went through the journey from getting the data to getting it to the hands of the physicians. And then we're going to do a 20-minute panel discussion on walking through few critical leverage points in that journey, right? Who makes those decisions? How do you gain physicians' trust, right? How do you roll it out? How do you measure success and so forth? So with that in mind, I'm going to hand it over to Drew.
Good morning, everybody. I guess we're the last talk before lunch, so we'll try to make it entertaining so that you guys can not think about lunch and think about what we're talking about. How many of you are familiar with the Kaiser Permanente system? Most of you, okay. And I suspect that some of the international folks are not. So Kaiser Permanente is a health system. It's an integrated system where health plan, hospitals, and medical group are all combined under one umbrella. It's not a single business. It's actually segregate businesses that negotiate every year to provide services for membership that we have. We have approximately 10 million members, a little bit more, across most of the West Coast, Colorado, and along the East Coast. And within that system, there are roughly 20,000 physicians that are contracted to provide the care. And over the last decade and a half to 2 decades, all of us have been sitting at our computer a little bit at a time, entering data as we see patients. And over that entire time, you might imagine that we've gradually accumulated an incredible amount of data, which Drew is going to talk about just how much data that is. But data that sits as a repository of your medical records is no better than paper data. But we begin to now think about if we had that data available for analytics, applying machine learning or even more conventional analytics, what are some of the information that we can begin to get out of this? So I'm an orthopedic surgeon. I've served in a variety of roles within Kaiser Permanente and various leadership roles, and I continue to practice. And some of you might be thinking, what is an orthopedic surgeon doing up here talking about data? Now, the long-term old reputation of the orthopedic surgeon is that we are roughly as strong as a mule and about half as smart. So in cases like that, what we've realized is that if we hire people that are really smart, like Drew, we'll begin to get some ideas as to what to do. And moreover, the members of the audience, no doubt, have a great deal of expertise in this area. So after we get through with our talk, we really are looking forward to you all participating in the discussion as to how best to use that data. So what are the main areas that we're focused in Kaiser Permanente for use of that data? And there's a variety of categories that we can talk about, but fundamentally we can talk about it in 3 to 4 categories. The first is obviously if we have that much data, we can begin to really create automation of some of the service that we do, because all of the practice that we've done over the course of the last couple of decades is codified in that data. So automation is one area. Automation, what does that mean? It's everything from, for those of you who are clinicians, chronic disease management, right, which you kind of don't need to use your brain, but you know what you need to do, but it's a matter of communicating with the patients to make sure they're under control. Can be a burden, but can we begin to automate some of that? To even image recognition, such as reading diabetic retinopathy images or even x-rays. Can that be automated so we as physicians can become more efficient in the work that we do? And then in the second category of work, what about decision support and predictive analytics? So in decision support, we take that wisdom of 20-some years of 20,000 doctors, and we begin to do some analytic, rather than the wisdom of the experience that we have, and we call it the practice of medicine. We call it the practice of medicine because when you graduate medical school and residency, you really don't know how to be a doctor at that time yet. You're just beginning. But over the next couple of decades, you have enough patients that you've seen that you begin to find patterns in the way you should be treating patients or the interventions that you should do. But imagine if you could take all of that knowledge and distill it so that every time you're making a decision on behalf of a patient, you have a second opinion, so to speak, tapping into that level of analytics. And we're beginning to do some of that work. And then in terms of predictive analytics, what if we could predict for you those members that are most likely to have a readmission, or most likely to have a fragility fracture, or have an initial admission for congestive heart failure or COPD? Could that be helpful in doing better population management? And we're beginning to do work in that area too. And then finally, this is kind of the cat's meow, right? What about this idea of personalized or precision medicine? What if you begin to search something on a search engine, and rather than it returning to you, I have a headache, it could be cancer, it could be migraine, it might be that you had a bad day yesterday. If it could actually tell you what it might be for you specifically, would that be something a little bit more helpful for people that are just interested in what might be going on with healthcare, with their own healthcare? Currently, it's the equivalent of if you were to Google, my checkbook doesn't balance, right? If you Google that, you would come up with all sorts of answers for why it might not be, right? It might be that you're bankrupt, hopefully not. Or it could be that you just made a math error. But we don't know, right? But if you go to the bank and you go to that site, it's very specific for you, and you can pretty much figure out why your checkbook didn't balance. Shouldn't that capability be available for healthcare? And we're beginning to explore that. Moreover, what about something that was alluded to earlier in the panel, about population management? Kaiser Permanente, we're all about population management, right? To keep our members healthy. We don't want people to get sick. We actually want people to stay healthy. And to do so, we need to make sure we do screenings and preventative interventions. But rather than trying to get 50% of 10 million members that might need this particular one, what if we could identify the exact 50,000 or so that has to have that intervention because it's meaningful, and we can get 100% of that? Could that begin to change the quality of care? And could that begin to bend the trend in terms of improved quality, better outcomes, and probably at a lower cost? So to give you some insights into that, I'm going to turn it over to Drew. Drew is an astrophysicist. He was a scholar at Caltech who was studying middle-sized black holes. Did you guys know that there's really big black holes, tiny black holes, and something in between, which is the middle-sized black holes? That was his expertise. And so he said, so I'll give you a lecture on that over lunch if you're really interested in that. Now, he decided one day that studying middle-sized black holes was fascinating and a great use of his mind, but that when it came right down to improving humanity, it may not have as much influence. But if you were to study the black hole in terms of healthcare disparities and healthcare understanding, that his knowledge might be more, what might say, valuably used. So we were lucky enough to steal him away from Caltech a couple of years ago. Interestingly, there's this once you bring somebody like Drew in, he can do all sorts of analytics for you, right? But as I was alluded to earlier, it's not just about data and analytics. It's about translating analytics into useful information in the hands of clinicians. And there is a significant gap there. And to talk to you a little bit about that journey that he's been doing over the past few years at Kaiser Permanente, let me turn it over to Drew to give you some insights in terms of some of the challenges that we have, some of the work we're doing, and then we'll open up the discussion so we can get your collective wisdom. Drew?
Yeah, so as Dr. Funahashi mentioned, my background is in astrophysics, and I've only been in healthcare for a little over 2 years. And actually, 2 years ago, I attended the AI Med conference here, and it was right after I had started, and I left inspired. I was like, oh, just going to go and apply deep learning, and we're going to be done by the end of the year, probably, with all of this. But I've learned all of the challenges that exist between what is the easy part of all of this is the data science and the AI generation, and getting that implemented and being useful in the clinic. And so what I want to do is kind of share some of the strategies and techniques that I've learned over the last couple of years that we've used to get past some of these barriers so that you can take the ideas and the inspiration you take from this meeting and bring them into your health systems. So these are all of the places that we're looking to touch with AI within KP, and we're very fortunate to be a data-rich organization. We have something like 44 petabytes of healthcare data. Just to give you an idea of what that is, if you wanted to put that on iPhones, you would need 1.4 million iPhones to store all of that data. And if you wanted to go really old school and put it on those 3.5-inch floppy disks, you would need enough of those floppy disks to circle the globe 65 times. So we have this immense amount of data. And it's not just the size of the data that makes it useful, it's the complexity and the richness that it has. Because of the integrated nature of our system, this data is very comprehensive. We have inpatient data, outpatient data, lab, pharmacy, imaging, and even things on the claims side. So we have the complete health picture for our members. Because we adopted the electronic medical record very early on, this is longitudinal. We have over a decade of data on millions of members. And another great thing about because we have this large group of members, and we're in areas like California, where the population is very diverse, we have lots of examples of patients and conditions that might be missing from other similar data sets. And so what we have really is the accumulation of 170,000 years of physician experience in this electronic medical record, and what we're trying to do is put that back to work. As Dr. Funahashi said, that was kind of painstakingly collected, one encounter at a time by our clinicians, but now we want to enable that to make their jobs more rewarding again. And so there is a big gap between having all of that data and being able to use it. And this is a lot of what we've been hearing about so far today. The electronic medical record itself is not designed for analytics. It's designed to be a transactional database where a physician can store data and retrieve data when they are treating their patient. But to really do analytics on that data, you have to take it out of that silo and make it available. And fortunately, KP has a strong foundation in being a data-driven organization. And so a lot of the technical infrastructure that's required to take that huge amount of data and make it available for analysts was already built and already in place when I came here. We've been using that data for descriptive analytics and research and quality improvements for a long time. And so what these groups have been doing is taking all of that healthcare data that's collected in different medical office buildings, different regions, different physicians, and putting it into a single repository where it's all together and doing some work to normalize that data so that when one group codes things a certain way, and another group codes things a different way, that is incorporated into this larger data set in a kind of a cohesive way. The other thing that happens as part of this process is you have all of the experts in the collection of that data there to make sure that that translation happens smoothly. And finally, we do a lot of enrichment of the data. It's been alluded to in a few of the earlier presentations. Although the healthcare data is one of the most important things for us, there's other data that influence a patient's health that we might want access to. And so we have groups that have been adding census data and other data from external data sources to our database for a long time so that that data can be useful. Now this is great. This is a great first step in making that data usable in machine learning models to generate AI, but it's not quite everything you need. And so right now, we're in a kind of a transition where we're trying to move from this kind of traditional analytic back-end data structure and move that into a system that is better supporting machine learning. And so what we need now are systems that can allow us to do very complex transformations and build complex data models on top of all of this raw data. And we want that to be done in such a way that that transformation can remain largely agnostic to the raw data source. And so what I mean when I say that is, when I'm taking, when we have a deep learning model, for example, we can't just shove a physician's note into there. We have to transform that into something the computer can understand. And so we have to take that text and turn it into embeddings, which are these representations that the model can understand. And we want a way that that can just be done automatically, and if something changes on the back end, there's just a simple code change, and our understanding of the model and the way that that data collected remains consistent. A lot of data cleaning has to go on, as I'm sure people who have worked with healthcare data know. It is very messy, and there's lots of data that's missing, and so we want to be able to fill that data in when that data is missing. And so we're looking at kind of interesting ways that we can do this process of imputation, which is filling in missing data, beyond kind of traditional techniques of just filling things with the means. There's some deep learning techniques that use things similar to collaborative filtering or generative networks to kind of fill that data in a more meaningful way. And then ultimately, what we want to build to is a place where there is a single kind of repository for all of the KP data that has been refined and prepped up for machine learning models so that that's been done in a consistent way, and that the people who are the experts in those particular domains have built the data model in a way that it can be deployed by other data scientists in different parts of the organization to make their models as effective as possible. This is something that we're challenged with right now, is that we have little pockets of AI all over the organization, and how can we kind of do this, build a more cohesive structure where we can not have to rebuild everything from scratch every time somebody gets an idea, but we can reuse the ideas that others have done, build on top of each other's models, and once little features that we put in the models have been generated, can we reuse those in different regions and different models? And so right now, I spend a lot of my time kind of banging my head trying to make the system that we have on the left work for what we have on the right, and then at the same time kind of evangelizing for moving forward to build out this system that we have on the right. And fortunately, there's a lot of great organizations and opportunities out there with platforms in the cloud that can really help to speed this process up. And so, this is a little bit about taking the raw data that is in the EHR and getting it ready for data science. But the data science it's the easiest part, or maybe I should say the most straightforward part, because it's just math. A lot of the tools that you need to do this are open source, so it's not even like a technology that's hidden away and only controlled by a few large companies that you have to partner with. This stuff can be deployed very easily. And the other thing is that we're also starting to see, as we saw earlier, a lot of these machine learning models are being accepted into the literature. So the technology is mature, and we know that there is very effective ways at using this data to build deep learning models that can accurately make predictions about health outcomes and make recommendations about individualized treatment plans. So really, the easiest part is the data science, the AI. And so I don't want to spend too much time on that because that's easy. So we have this challenge of taking the raw data and getting it ready for the data science that I've talked about. And then we have the very fun part that I wish I could spend more of my time doing, which is the data science. But then at the end of the day, all that we're doing when we get this far is an academic exercise. And like Dr. Funahashi said, I was tired of academic exercises. I don't care how accurate my model is. If it's not in the hands of a clinician who can use that model to improve the way that they're delivering care, it's pretty useless, right? So the big challenges are in taking those models and getting them into the hands of clinicians so they can start impacting health outcomes. And so here's a few examples of places where we've had successes and challenges in doing that. And so one place that is key to have alignment before you start building out an AI system is in workflow integration. And the story I have behind this is around high utilizers. So this is a very common issue in healthcare organizations. We have this small proportion of patients, something like 5% of patients, who are responsible for 20% of all utilization. And we want to be able to find these patients so we can effectively treat them and prevent them from becoming these very high utilizers. And so I was asked, can you predict these people years in advance? And it turns out this is possible with the data we have. Using a bunch of clinical factors and a bunch of tracers of people's kind of social situations, we were able to build a suite of very powerful models that can accurately identify patients who are likely to be high utilizers up to 3 years in advance. We can do it even further in advance, but the model starts to degrade in performance as you go further back in time. And so this was really exciting. We had this great model. We could identify these patients. The nice thing about the model is it's interpretable, so we can understand why a model is saying a particular patient is at risk. But the challenge is we would show the predictions to clinicians, and they said, I don't really know what to do with these patients because they're not healthy, but they're not very sick, And so really what we found is that for a lot of these patients, what's driving their high utilization is unmet psychosocial needs and not just clinical issues. And so we've been having a hard time implementing this model into a workflow, but the kind of silver lining to this is that it's given us the opportunity to start exploring new interventions that reach out into the community to serve our members in these areas where it's clearly impacting their healthcare, but we're not meeting those needs right now. Another aspect of implementation that you also want to think about is how you roll out your AI solutions. So even if you have a perfect workflow that your solution can fit into, you need to kind of think strategically about the best way to start deploying that program. And so in Kaiser Permanente in Southern California, we have a pretty robust teledermatology program. And so there's a few different channels that this works through. One is by a kind of a physician-to-physician channel, where a primary care physician can have a patient in his or her office, and if they have a dermatological skin condition that the primary care physician is not sure about, they can take a photo of that and send it to a dermatologist and get a kind of a consult, a virtual consult with a recommendation for a treatment plan is sent to them completely virtually, or if that patient requires follow-up in dermatology, they're fast-tracked into a derm consult. We've also experimented with doing this direct-to-consumer, where through our KP app, a patient could take a picture of a skin condition and send that and have that reviewed by a dermatologist. So what we really have here is an amazing training set where we have thousands and thousands and thousands of images that have been submitted by patients or physicians and reviewed by at least one, often two dermatologists. So this is a training set so we can build up an AI tool that can actually do that initial diagnosis instead of requiring a dermatologist to do it. But the question becomes, how do we roll this out? Where do we put this into this complex teledermatology workflow that we have to make sure that it gets adopted? And because this is still a somewhat experimental tool, we're still learning how well it works. We want to make sure that this is in the hands of clinicians. It's not ready for prime time for this to be used independently by a member, but by giving it to a physician as a decision support tool, that gives them the opportunity to act on that prediction and change the way they were going to deliver care. And we're thinking about different types of clinicians to use it, people who are really interested in the telederm program, all the way down to those who don't use it. And one of the things we've learned is from the primary care physicians is that they think this is an interesting educational opportunity for them to learn more about these dermatological issues that they maybe forgot about after not seeing them for many years. And the final thing is that, in order to be really successful, you need to make sure whatever you're rolling out is aligned with your organizational priorities. And so, as Dr. Funahashi alluded to earlier, chronic disease management is a major challenge for all healthcare organizations. And it's one of these challenges where all of the treatment is basically, for the most part, done by protocol. So it's not something that really requires the physician's clinical acumen, and it just leads to a lot of indirect work that can be kind of frustrating. And so to combat this and help get better quality for our members, which is a regional or an organizational imperative, we have a bunch of nurse care managers who work to manage the diabetes of our diabetic patients. But we wanted to kind of supercharge those nurses, so to speak, with an AI tool that helps identify the patients who are most at risk and recommends a treatment plan for each patient that's personalized to that patient's needs. As we went through and started this process, we wanted to interview the care managers to really understand how they could use this tool. And we learned these people they're great, they're very passionate, and they're super compassionate, and they're very effective when they're talking with a patient. But one of the challenges they have is that they don't really know which patients to reach out to, and they often have challenges just connecting with a patient. And so instead of being a reactive system where a patient has to come in for a new blood test or something before the care manager is alerted to reach out to them, we're building this suite of predictive analytics all around diabetes to kind of prioritize patients who need that care, and then also building a recommendation system on top of it so that not only are we telling the care managers who to reach out to, we're helping them figure out what the best thing to do is. And so I kind of flew through this, but if you're going to roll out an AI project, you need kind of a synergy between a bunch of different, three main things. You need clinician buy-in because they're the ones who are going to be using this, and if they're not championing your project and having a workflow where they're going to use it, it's not going to happen. Your use case needs to be aligned with organizational priorities because this is an expensive investment, and if it's not an organizational priority, it's going to be hard to get all of the infrastructure you need in place. And lastly, you need to be able to make the prediction, but as I said, in my opinion at least, that's the easiest part of all of this.
So, we had originally planned for 4 questions, 4 things to discuss, but given that we have about 7 minutes or so, what we're going to do is we are going to do 2 questions directed at the panel and give back 5 minutes to the audience to ask questions. Fair? So that being said, I'm going to focus on the trust and impact side of things, right? I think we do not talk enough about it simply because they are further downstream, but I think it sometimes helps if you understand what you are building for, right? And I think, Kaiser being so far ahead in the continuum is a perfect organization to ask that question, saying having worked on this for 3 to 4 years or more, right? How do you get the trust of care managers and clinicians at the ground level as you roll things out? So, Dr. Funahashi, do you want to get it going?
Sure, I'll take a first crack, and I'd be interested in the audience's perspectives on this too. So I think it's not any different than any literature that we read, right? So there's some new article that comes out in the journal, and we read it. Sometimes it's consistent, which just is a validation of what you're doing, and sometimes it's inconsistent. And yet sometimes those new findings are meaningful. And as clinicians, we then need to take that information and determine whether that new information that's coming in is something that we're going to change our practice, or if it's something that we're going to wait, or do we determine whether other people are going to do that, and it ultimately becomes community practice. So that's fundamentally the way we gain trust with any new piece of information that comes in. So initially, as we're doing this, for dermatologic readings as well as the care managers, we would bring this data to the people in parallel. So does it, so to speak, resonate with what they're typically doing? And then over the course of time, and in fact, that is a validation we should be doing anyways, right? To make sure that the information and the analytics that the data is bringing us is consistent with what we believe our clinical judgment to be. And over the course of time, as you get more and more familiar with it, and we have some examples of that, then you begin to rely a little bit more on the additional information that the analytics is giving you. So then you begin to take that additional information and then weigh it with your clinical decision making. At this point, I do not believe that AI or artificial intelligence or insights from machines will independently make clinical decisions, because at the end of the day, we still need clinical judgment, number one. And number two, that relationship and that trust that the patient has is not with a data source. It's actually as a human with the humanity of the relationship they have with their physicians and their nurses. So I think we have to make sure that we don't disrupt that relationship in bringing additional data and information to the clinicians.
Thank you. Drew, do you want to add to that?
Yeah, I mean, from the data science side, what we can do is make sure that the models we're building are what we call interpretable, so that we can have some way of explaining why this particular conclusion that the model has come to was made. And if you can't do that, if it's just a black box, which is one of the challenges of using some of these deep neural networks, which can behave like black boxes sometimes, it's really hard to build that trust. But as Dr. Funahashi said, iteratively developing models in partnership with the clinicians, I think goes a long way to help them understand the process that we're going through, and that helps them understand that this is a reliable and robust system that we're developing.
Thank you, Drew. So we are not going to do any more questions because I want to give some time to the audience to ask questions. Yes, sir.
In your opinion, what is the most efficient way of getting outpatient data, let's say for heart arrhythmia or anything that you want to detect, and make this AI more fluent and to be licensed by your medical groups, or you license it to say, okay, we certified this method. What's the best option for the infrastructure, moving that outpatient data, integrated to the EMR, and make use of it and make the cardiologists be happy for the cost?
Yeah, really good question. I'm going to have Drew take that on too, but we do have the advantage in our system that all ambulatory, meaning outpatient, inpatient, insurance data all lie within our own, so to speak, walls of Kaiser Permanente. So when we're looking at combining outpatient data to predict inpatient or need for admissions or inpatient activities, that's all a part of our data set. And I would say that there's two challenges. One is in cleaning up, so to speak, the structured data sets we have across different regions, because every doctor, so to speak, at different regions of Kaiser Permanente practice a little bit differently. And the number two, which is probably common to most of you too, is that the richness of the data actually lies in the consultation notes and the progress notes that the physicians write. And that's the unstructured data. And I think there are systems that actually can begin to compile that unstructured data well, and some of that we're working on, although I guess because of our contractual relationships, we can't tell you who we're working on that with, but I think there's some opportunity to do that too. So we can actually take, in our setting, ambulatory, inpatient, and additional data, and enroll all of that into making the analytics and the decision support that the physicians are looking for. Drew, you want to?
Yeah, and just to add on to that, we're very fortunate to have all of these different sources of data. But one of the other things that we're looking into is, how is we build more systems that allow our patients to generate their own data remotely. How can we incorporate that data into our models as well? And so, one of the other things our department works on is virtual care. So it's very important for the data team to be involved early on in those projects, so that that data is being collected in a way that can ultimately be folded into the other work we're doing.
Yeah, hi, over here, Steve Racing with ASMGI. So my question, in staying consistent with the theme of trust, I think setting realistic expectations is a big factor in creating that environment where you have the trust, right? So machine learning has to learn. It takes some time to get a viable outcome from a model. How do you manage that at Kaiser? And I mean, how long does it take, right? What is a good, reasonable expectation of how long it takes?
Drew, you want to take on how long it takes to do the data?
Yeah, I mean, so that's a complicated question, right? Because once the data is prepared, it can be pretty rapid, a few months time scale that we can make a model that can make a prediction. But the challenge is oftentimes the data we need isn't in the format we need it to put it into the model, and so there's a big slowdown in making sure that data pipeline is built. And then on the flip side of that is, the model can only, when we build a model, we train it on retrospective data, and so we can only tell how good it performs on this previous data set. To really get a return on a machine learning model, we need to put that into action in a clinic and have an intervention paired with it where we understand that model is actually getting that intervention to people more efficiently. And so when we're talking about what the return on investment for one of these machine learning models is, it's a very long process of having the model and then using that to actually change the way that care is delivered. And there's a big disconnect between the two because there could be that we can predict something with great accuracy, but even knowing that about the patient, it's hard to get them to enrolled in the intervention program that's needed to change the outcome we're predicting.
And Drew, if I can add a little more thought, additional thought to that, right? I think the framing we use for AI is less about artificial intelligence and more about assistive intelligence, right? It starts with A. But having said that, in the clinical context, this is an 18-month journey, right? You do a pilot, you do a proof of concept to show that this works. You do a pilot to say that it can be used, and then you roll it out. But the silver lining is that not all application of AI in the clinic, in the healthcare context has to be in the clinical context. There is a lot that AI can do on the operations side, on the how do you staff people, right? How many people will show up in ED? How many nurses do you need? You have a lot of applications of AI on the financial side of the business. How do you do bundle payments, right? Those things are slightly lower in risk. The data is slightly more clean, and if you can show the value of it, things fly much faster, right? So there is a lesson and talk there for next AI Med as to how do you prioritize what battle you fight first up and what do you fight for a long time.